Bismillahirrahmanirrahim. Assalamu alaikum. Welcome into the third episode of our discussion on adipose tissue. Today we shall discuss very unique aspects of the adipose tissue. And after completion of these three basic understanding vlogs, next we shall discuss our discussion on understanding adiposity. So let's start. Bismillahirrahmanirrahim. Today is the part 3 of our discussion on adipose tissue, and this is, I must say, a special edition of our discussion on understanding adipose tissue. Today we shall discuss very unique aspects of the adipose tissue, that is the thermogenesis versus lipogenesis. Then we shall discuss the genetic and epigenetic control of adipose tissue. And then we shall discuss the adipose tissue and fertility, especially in polycystic ovarian syndrome and obesity. And then the sleep and circadian rhythm effects on adipose tissue regulation. So these are the four very important and unique aspects of adipose tissue, and it gives us understanding and platform to understand the metabolic dysfunction. So let's start with our discussion on thermogenesis versus lipogenesis. The thermogenesis, we can define this as the process of heat production in organisms, especially through fat metabolism. So thermogenesis, by and large, is the process of heat production in organisms, in human beings, especially through fat metabolism. The primary sites of thermogenesis is brown adipose tissue and beige fat. The mechanisms of the thermogenesis, it's mediated by uncoupling protein 1 in mitochondria. We discussed in our first session that the brown adipose tissue has abundant of mitochondria, and there the thermogenesis happens, the heat is produced, and this is mediated by the uncoupling protein 1. And instead of generating ATP in thermogenesis, energy from fat oxidation is released as heat. It's activated by cold exposure, beta adrenergic stimulation, and certain hormones like irisin and FGF21. The purpose of thermogenesis is it helps maintain body temperature, especially in newborns and during cold exposure. Then the lipogenesis. We can define lipogenesis as the process of fat creation, mainly from excess carbohydrates and proteins. When we have the intake is more in carbohydrates, proteins, they are converted into fat. The primary sites of lipogenesis is liver and white adipose tissue. The thermogenesis was brown adipose tissue, here it's the white adipose tissue. And the key enzymes involved in lipogenesis are acetyl coenzyme A carboxylase and fatty acid synthase. The hormonal control for lipogenesis includes it is stimulated by insulin, and it is inhibited by glucagon and AMPK activation during fasting and exercise. And the purpose of lipogenesis is that it stores excess energy in the form of triglycerides and adipose tissue. We have discussed this in our first session, so this is the important point. So what is the clinical relevance of thermogenesis versus lipogenesis? In obesity, the excess lipogenesis and impaired thermogenesis is there, and that's the reason we see the metabolic dysfunction, different ways of expression in that. In therapeutic focus, it enhances, if we can enhance thermogenesis via BAT activation or browning of white adipose tissue, and it's a promising obesity treatment strategy. So these concepts of thermogenesis and lipogenesis can be used for therapeutic purpose as well. Now the second unique aspects of adipose tissue, the genetic and epigenetic control. The genetic regulations, the adipose tissue development and functions are influenced by multiple genes. These include PPAR gamma. It's a master regulator of adipocytes differentiation. You should remember this. Then the uncoupling protein 1, it's a key for brown fat thermogenesis. So the PPAR gamma, it will give you more adipose tissue, and this will burn out the adipose tissue. Then the leptin gene and the adiponectin gene, the LP and ADIPOQ, that is the adiponectin gene and leptin genes, they control appetite and insulin sensitivity. The polymorphisms in these genes may affect susceptibility to obesity, insulin resistance, and lipodystrophy. Now, it has been found that if there's polymorphisms, there are mutations in these genes, they can lead to obesity or insulin resistance or lipodystrophy. Then, what about the epigenetic regulation? The epigenetics refers to change in gene expression without altering DNA sequence. Even gene is there is no DNA sequence alteration, but still the phenotype or the way it presents in real is changed. It is often due to DNA methylation and histone modification and non-coding RNAs, that is microRNAs. So these three ways are the mechanisms where the gene expression is changed without altering the DNA. So this is influenced by prenatal nutrition, maternal obesity, or undernutrition. Both affects the epigenetic regulation of adipose tissue in the infant, and environmental factors like toxins, stress, and exercise, and diet and microbiota, of course. So when we take the genetic and epigenetic regulation, what is the clinical relevance? Epigenetic changes in adipose tissue can lead to lifelong effects on obesity risk. So we should be aware of it. And there is promising area for personalized medicine and early life intervention to prevent metabolic diseases. So it opens a window where you can do preemptive interventions and you can prevent the development of metabolic dysfunction. Now, the third important concepts of today's discussion, adipose tissue and fertility, especially in polycystic ovarian syndrome and obesity. What's the obesity and fertility relationship? The excess adipose tissue leads to increased aromatization of androgens to estrogens. We know that. And there is disrupted hypothalamic pituitary gonadal axis. And there is elevated insulin levels promoting ovarian androgen production. And the polycystic ovarian syndrome and adipose dysfunction association. In polycystic ovary syndrome, central obesity and insulin resistance are common. We know this. And the adipose tissue secretes leptin, resistin, and TNF-alpha, which disturb follicular maturation in the ovaries. And the adiponectin levels are reduced, worsening insulin resistance in such cases. The visceral fat accumulation worsens anovulation, hirsutism, and infertility. So all these are interconnected phenomena there. Then there was the clinical relevance of adipose tissue and fertility. The weight reduction improves ovulatory function and fertility in polycystic ovarian syndrome. Therefore, the different medications are given to these women for weight reduction. And metformin, GLP-1 analogs, and lifestyle changes are key intervention targeting adipose dysfunction. Then the last component of today's discussion, sleep and circadian rhythm effects on adipose tissue regulation. So what's the sleep and metabolic regulation concept? Poor sleep quality and sleep deprivation leads to increased ghrelin or hunger hormone. So people feel hungry. And decreased leptin satiety hormone. So there's more intake of food. Leads to elevated cortisol and insulin resistance. These changes promote increased appetite, fat storage, and reduced energy expenditure. The circadian rhythm and adipose functions. The adipocytes have their own circadian clocks that regulate lipid metabolism, insulin sensitivity, and adipokine secretion. So there is a adipose tissue circadian clock, and it regulates these three important aspects. Disruption of the circadian rhythm, that is night shift work, jet lag, leads to dysregulated fat storage and altered thermogenesis, an increased risk of obesity, diabetes, and cardiovascular disease. So the sleep and circadian rhythm affecting the adipose tissue regulation, the clinical relevance is that chrononutrition, that is the timing of the food intake, and sleep hygiene are emerging tools in obesity prevention. So this is the new aspects of managing obesity in our patients. Aligning eating and activity with circadian rhythm improves metabolic health. So this is another aspect of dealing with these patients. So dear colleagues, if you summarize today's discussion, the thermogenesis versus lipogenesis, the key mechanism, energy expenditure versus storage, and the clinical relevance, the obesity and metabolic syndrome, that it is associated with these two. Then the genetic and epigenetic control, the gene expression and early life programming is the key mechanisms, and the clinical relevance, it opens a window for personalized medicine. Then the fertility, polycystic ovarian syndrome, obesity, the key mechanism is hormonal imbalance, adipokine dysfunction, and the clinical relevance, its association with infertility, and it's important, gives the important means of managing polycystic ovarian syndrome patients. And the sleep and circadian rhythm, which we discussed lastly, the key mechanism is hormonal dysregulation, appetite control, and its clinical relevance, that this is related with the obesity, diabetes, and cardiovascular risk. So, dear colleagues and PGs, if you found this video useful, please do like, share with your colleagues, and subscribe to my YouTube channel, Medicine Made Easy. Inshallah, next we shall start our discussion on adiposity. What is adiposity? What are its types? What are its causes? What is its clinical relevance? How it is regulated? All these points. And to understand adiposity, we should have understood the adipose tissue, and that's the reason I gave 3 dedicated sessions on understanding adiposity. Know the adiposity, the adipose tissue. Know the adiposity is the abnormal accumulation of the adipose tissue. And then we shall go for our discussion on obesity, and then we will understand the difference between adiposity and obesity, because these are the important aspects to know before we embark upon the discussion on metabolic dysfunctions. This is the era of metabolic dysfunction. In the current century, this is going to be metabolic dysfunction, and then its genetic control and its control at the very basic levels. So be with me. See you in the next episodes on our discussion on adiposity, a very, very important concept. Till then, take care. Khuda Hafiz.